Once the training is done, before that we have to define certain of these parameters in the files that I have shown. It is cafe train val1.prototext for the solver, and it's for the model it is train underscore val.prototext for the model definition. Prior to that, I would also like to show you couple of pre-processing functions that does the image transformation and the histogram equalization. And the make datum function takes an image and generates a label for that function for that particular image, and we fire the following command to generate the mean image from all the images that we have in our data set. This is a common pre-processing step in deep learning models. So after we define our model and we define our solver, we fire the following command in Ubuntu to get the model going. This trains the model on 25,000 images, and it saves the results of this training in a log file called model_1.train. And one of the important things to always observe while training a model is the learning curve. So in our model, a learning curve is seen to achieve a 90% accuracy, and the improvement in learning stopped after about 3000 iterations. These learning curves are very useful to visualize the training and the validation losses and the validation accuracy at the training stage. This graph indicates the results that I was talking about. And now, after training our model and seeing its learning curve, we try to get a prediction on the unseen data. We feed images to the model that it has not seen during its training and try to see how it fares on labeling images that were not seen during its training phases, and correctly guess whether it is a cat or a dog. So we need 4 files to run this predictor. One is we will use the test images, then we will use the mean image, then we will use our model architecture file, and we'll have trained model weights also, which we computed during the training phase. The mean image is stored under a mean array. That is the part that I have illustrated in my snapshot, and defines a model called net by reading the deploy file and the train model, and defines the transformations that we need to apply on the test images. So in the next slide, I will show you some of the outcomes of this result. The output is customized to print results in this way, percentage and whether it is a dog or a cat. For this particular image, it is 99.52% that sure that it is a cat. That is the accuracy with which it can tell, the high confidence. For a dog, it was almost 100% sure. There were some failure outcomes that led to the reduced accuracy of our model. Cases like this, where the system wrongly classified the image as a dog, and overall the accuracy that was achieved was almost 90%. So this is the result that was achieved in a model that was trained from scratch. As you can see, in this day and age, this is a pretty low figure, so I tried to extend the accuracy of this, and one of the techniques that was recommended for increasing accuracy was the concept of using a pre-trained model. So here we have an input photo on our trained model. It says whether it's a dog or a cat. We can have a pre-trained model, and it can also tell, we can input our photo and it would adjust and be able to predict whether it is a dog or a cat. The motivation for using pre-trained models are the following: that a convolutional neural network requires a large number of data and high computational costs to train. Some of the networks take up to 2 to 3 weeks, even despite using multiple GPUs. By using transfer learning, we address both the problems. It is efficient as well, it achieves a high accuracy. So by using a trained model, we adapt it to the problem that we are trying to solve. For example, we have a model which is trained on 1000 categories. We can downsize it to about 2 in this particular case, just for a dog and a cat. This is called as transfer learning, where the learning done on a different model is applied to our particular scenario. So in our project, we have used the Cafe Model Zoo, which is a repository that is used by researchers and machine learning practitioners, where their trained models are shared with one another. As stated earlier, this was created by the Berkeley Vision and Learning Center. This library is called the Model Zoo, and it was trained on the ImageNet dataset, which contains millions of images of various kinds of animals across thousands of categories, and it could involve non-animal images as well, but in our case we have adjusted the output to 2 given the requirements of our project. It was downloaded to our particular machine by wget dl.cafe Berkeley Vision, and we downloaded the model, and we had to define the model and the solver similar to what we had done while training the system from scratch, and they were fired using the following commands. And after using a pre-trained model, just after 1000 iterations, a model was able to display an accuracy of 97%. It achieved a higher accuracy than training from scratch with just a fewer number of runs, and it was shown to be overall much more efficient. So by comparing these two methods, we can clearly conclude that transfer learning is a much more efficient and less time consuming task than training your own model from scratch. We can see that existing powerful architectures like CNN are only enhanced for the better by using these techniques, and architectures and commonly used libraries in deep learning were learned through this implementation. In my next slide, I have listed what I have used. Thank you. This is the code that was used for the learning curve plotting, and this was to create the two databases within the training images for training and validation. This was the source script, Python script, used for applying the image transformation as part of the data pre-processing and generating the mean image and defining the image transformations, and finally making the prediction and saving it to a CSV file as part of our submission. And this was a helper function written for the image processing, and this does our making predictions as well. And the remaining files which were used were the prototext file and for the deployment of the codes, and after every 10,000 iterations, the cafe model would take a snapshot and save it in the cafe model _1 iter.10000 with the extension .cafe model.